Hello dear student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in previous lecture we have seen meromorphic function theorem. We have stated and then we have proved that meromorphic function theorem. So in this lecture we will see some problems on a meromorphic function theorem. Okay, so let us we take the first example. What is the first example? Evaluate integral over gamma twice z upon z square plus 1 dz where gamma is mod z equal to 2. Okay. So here gamma, which is represent a circle, that is mod z equal to 2, whose center is 0 and radius is 2. Okay. Gamma is a curve which represent a circle, that is mod z equal to 2. Okay. Now we have to find out the solution of the value of this integral. So we have given integral over curve gamma twice z upon z square plus 1. So here f of z is z square plus 1. Okay. Then the given integral of the type, that is integral over curve gamma f dash of z upon f of z dz. Okay. So this is the value of f of z and derivative of f of z is, that is twice z. That is, this is the form of these types of integral. Okay, so therefore here f dash of z is twice z. Okay, so here f of z is a polynomial function and we know that every polynomial function is an analytic function. Okay, so f of z is a polynomial function, so therefore it has no singularities. Okay, so therefore it has no pole. But as f of z equal to z square plus 1, so this can be written as z minus I z plus I. So therefore z equal to I minus I are the zeros of the function f of z. Okay. So therefore by using the argument principle, 1 upon 2 pi integral over curve gamma f of z divided by f dash of z, that is twice z, I f dash of z, that is twice z upon z square plus 1 dz equal to index of closed curve at a point I plus index of closed curve at a point minus I. Okay. So index of closed curve gamma at a point I, which is 1, because we have given a circle whose center is 0 and radius is 2. Okay. So therefore this index of closed curve lies inside the circle. So this point is lies inside the circle and this is point is also lies inside the circle. Okay. So therefore index of closed curve at a point I and at a point minus I will be the 1. So therefore 1 plus 1, that is 2. Okay. So transfer this 2 pi to RHS side. So we will get integral or curve gamma twice z upon z square plus 1 dz equal to 4 pi I. So this is the value of the given integral. Now we will solve the second example, which is given as integral over gamma twice z divided by z square plus z plus 1 dz, where gamma is a curve, and which is given as mod z equal to 2. Okay, and second curve is given as gamma is curve mod z minus I equal to 1. So this is the for example number 3. Okay, what is given? So we have given f of z equal to z square plus 1. So from this equation we can uh, consider f of z is z square plus z plus 1. Okay, so if you observe, so this is the integral of the type, that is integral over curve gamma f dash of z upon f of z dz. Okay, so therefore f of z is twice z plus 1. So differentiate with respect to z to this term, we get f dash of z equal to twice z plus 1. Okay, so here f of z is a polynomial function and it has no singularities. Okay, but f of z is z square plus z plus 1. Okay, so therefore the solution of this term can be written as z minus 1 by 2 plus root 3 upon into I, and second is z minus 1 by 2 root 3 upon 2 into I. Okay, so this is the solution of this term. Okay, so therefore by using the argument principle, so this is z minus a first point and this is z minus a second point. So by using the argument principle, 1 upon 2 pi I integral over cor gamma 2z plus 1 upon z square plus 1 z square plus z plus 1 dz equal to index of closed curve at point this, that is minus 1 by 2 plus root 3 upon 2 into I, plus index of closed curve at point this, that is minus 1 by 2 minus root 3 upon 2 into I. Okay, the value of this index of closed curve at point this will be the 1, and also the value of this curve at that point will be the 1, because we have given a circle whose center is 0 and radius is 2. Okay, so therefore these points will be inside the circle. So therefore the index of closed curve about this point is 1 and index of closed curve about this point is also 1. So therefore 1 plus 1, that is 2. So transfer this 2 pi I to right hand side, we will get the value of this integral is, that is 4 pi I. Okay, so similarly we can find out the integral curve for this circle, that is z minus I equal to 1. Okay, so by using argument principle we can write directly 1 upon 2 pi integral over curve twice z plus 1 z square plus 1 dz. Okay, so index of closed curve at a point we have given this point and again for this point. Okay, so here means here center is I and radius is 1. Okay, so according to the index of closed curve, the index of closed curve at this point, the value will be the 1, and the index of closed curve at a point this, the value will be the 0. Okay, so therefore 2 pi, so transfer this 2 pi to right hand side, the integral value of this term, that is 2 pi. Okay, that is z square plus z and so on, 2 pi I. Okay, so this is a very simple example. Example number 4, we can take example number 4, that is if f of z equal to z to the power 5 z minus 2 to the power 3 upon z minus 1 square into z plus 1. Okay, so here we have to find out the integral over cor gamma f dash of z upon f of z dz, and gamma is given as mod z equal to 3, which represent a circle whose center is 0 and radius is 3. Okay, so we have given here z to the power 5 z minus 2 to the power 3 upon z minus 1 square into z plus 1. Okay, so here f of z has a 0 at, if you observe from this given f of z, so here f of z has a 0 at z equal to 0 with the multiplicity 5 for this term, with multiplicity 5, and at z equal to 2, at z equal to 2 with multiplicity 3. Okay, also f of z has a pole at z equal to 1 of order 2 and z equal to minus 1 of order 1 from this. Okay, so therefore here zf means 0 of function, that is 5 plus 3, that is 8, and poles of the function f, that is 2 plus 1, that is 3. Okay, so therefore by using argument principle, 1 upon 2 pi integral over cor gamma f dash of z upon f of z dz equal to 8 minus 3, that is equal to 5. Okay, so transferring this 2 pi to right hand side, we will get the value of this integral is to 10 pi I. 2 pi into 5, that is 10 pi I. Okay, so these are the some examples on argument principle. Now we will see the another theorem, that is let F be a analytic in an open set containing a closed ball whose center A radius R. Let F be a 1 on open circle or open ball with center A radius R. If omega equal to function open circle center A radius R and gamma is a circle mod z minus A equal to R, Then f plus w is defined for the each w belongs to omega by the formula, or we can say f dash of w 1 upon 2 pi integral over core gamma z f dash of z upon f of z minus w dz. Okay, so we have to show that this formula theorem. Okay, so to prove this theorem, let us define a function that is f of z equal to f of z minus w, where z belongs to open circle whose center 0 radius r for any point w belongs to omega. Okay, now clearly f of z is analytic in a open circle center a radius r. So moreover here f dash of z equal to f dash of uh, uh, capital F dash of z equal to small f dash of z, because f belongs f containing in open circle whose center a radius r. W belongs to f. Okay. So therefore there exists z belongs to open circle whose center a radius r such that f of z0 equal to w. Let us reconsider equation number 1. And hence by the definition of the f, from this definition of f, from this f of z0 equal to 0. F of z0 equal to 0 because f of z0 equal to w. So therefore put add z equal to z0, so we will get f of z0 is 0. Okay, so that means we can say that here z0 is the 0 of the function capital F. So therefore capital F of z has no pole, means that is f of z is analytic function. Okay, now let us we take g of z equal to z. So clearly we can say that g of z is also analytic function. Okay, so therefore by using generalized argument principle, 1 upon 2 pi I integral over core gamma g of z f dash of z upon f of z dz equal to summation j equal to 1 to n g of zj index of closed core at a index of closed core along the core gamma at point zj minus summation k equal to 1 to m gpk index of closed core along the core gamma at a point pk. Okay, so which is given as 1 upon 2 pi integral over core gamma. Okay, g of z we know that is z. Okay, so put the value of g of z, that is z f dash of z upon f of z dz as it is equal to 1 upon 2 pi m. Okay, so this can be written as integral over core gamma z f dash of z upon f of z minus w dz. This can be written as. Okay, so here g of z0 index of closed core at a point z0. Okay, so which implies the value of this term is that is z0 and the value of term is that is 1. So therefore z0. So which implies f dash of w by using equation number 1. By using equation number 1. Okay. So therefore f dash of w equal to 1 upon 2 pi integral over core gamma z into f dash of z upon f of z minus w. Okay. So this is the proof of the given generalization of the argument principle. Okay. So dear student, here we have seen some uh, problems on argument principle, and also we have seen one theorem, that is the generalization of the argument principle. Okay, so in next lecture we will see another points on in a unit number 3.